Welcome to The Explainer. Today, we're unpacking a devastating 2005 aerospace mystery, and we're actually going to use it as a Trojan horse to expose the absolute biggest hidden risk in your 2026 AI integrations. So, picture this. It all starts with a photograph taken in Toulouse, France back in late 2005. Honestly, it's a photo the Airbus communications team desperately wished had never seen the light of day. It just showed a thick, braided bundle of colored cables, a wiring harness, resting against an aircraft fuselage panel. But there was a gap between them, a gap that physically just shouldn't have been there. And believe it or not, that one simple photograph of a gap completely unraveled an entire corporate empire.
Let's put this into perspective by looking at a truly staggering figure, 4.8 billion euros. That number right there represents the massive financial fallout caused by that single gap in the wiring harness. And the human cost at the executive level was just as severe. Because of this one issue, 3 of the absolute most senior executives in European aerospace were gone in just 4 months. But here's the truly fascinating part. Nobody actually made a mistake. Nobody was negligent. It wasn't bad engineering, and it definitely wasn't incompetent management. Instead, as we're going to see, this multi-billion euro loss was the direct result of a structural disease that kept a massive failure completely invisible. Now, to even wrap our heads around how that's possible, we have to consider the sheer scale of the Airbus A380. This was Europe's absolute prestige project. It was meant to prove, once and for all, that a multinational partnership could literally out-engineer Boeing. By 2004, each aircraft contained 530 kilometers of wiring. That's over 100,000 individual wires per plane. At the time, the accepted wisdom in aerospace management was this concept of distributed excellence. Basically, you hire the best engineers in France, Germany, the UK, and Spain, you hand them the specific work packages they excel at, and then you just integrate the whole shebang in Toulouse. And ironically, for years, the dashboards reflected that this plan was working flawlessly. We really need to understand how a massive project like this, with perfect, all-green status reports from every single national team, could still fail so spectacularly at final assembly. Because everything looked absolutely fine, right up until the physical wires actually arrived.
And this perfectly illustrates the foundation of the crisis. This is the carefully allocated national work share within EADS, which was the parent company of Airbus. Notice how the work is chopped up. Hamburg is handling the fuselage, Toulouse is doing final assembly, the UK has the wings, and Spain is building the empennage components. This setup wasn't an accident. It was deliberately designed as a political balance. They specifically wanted to keep French and German industrial capacities in a state of total equilibrium. They even had dual co-CEOs. But it had a fatal flaw. It was a politically balanced structure that entirely lacked a central authority. There was nobody who could step in and actually force technical standardization across those national borders. So that lack of central authority essentially created a technical time bomb. In Toulouse, on the French side, the engineers had upgraded to CATIA version 5. This was a completely new, ground-up 3D digital mock-up environment. Game-changing stuff. But over in Hamburg, the German team was still using version 4, which was a 2D parametric system. Now, we're not just talking about different software versions here. These were completely incompatible architectures. Upgrading Hamburg would have meant significant retraining, project delays, and some seriously heavy costs that the German organization just didn't want to absorb. And because there was no single boss who could force the issue over a national objection, leadership simply avoided making a decision on the incompatible toolchains. It was swept under the rug. And that left catastrophic errors completely invisible at the data boundary. Hamburg's 2D model looked perfectly fine. Toulouse's 3D model also showed zero problems. The data simply didn't translate cleanly, meaning those errors only showed up in the real world when a physical wire harness was built and shipped down to France.
The problem is, fixing a physical wiring harness means re-engineering the routing and physically remanufacturing the plastic and wire, literally aircraft by aircraft. Because of this, that invisible software gap built up into a devastating cascade of delays. In June 2005, Airbus had to announce a 6-month delay. A year later, they added another 7 months. And by October 2006, another full year was tacked on. What we're watching here is an invisible technical gap translating into a multi-billion euro market wipeout over the course of 3 massive announcements. I mean, just following the June 2006 announcement alone, EADS lost roughly 26% of its market capitalization in a single trading day. Just poof, gone.
The real crux of the issue was captured perfectly by Streiff. He was a noted turnaround executive brought in as CEO specifically to fix this exact crisis. Well, he lasted about 100 days. Upon resigning, he told the press, "I cannot fix this," because the structure that caused it is still in place. Think about how incredibly powerful that statement is. The root cause was an unbridgeable organizational authority gap. It wasn't a broken wire. He realized he simply didn't have the structural power to force a cross-national technical change. The org chart that created the problem was actively preventing the solution.
And this historical disaster brings us perfectly to Conway's Law. Formulated way back in 1967, it states that any organization designing a system will naturally produce a design whose structure perfectly mirrors that organization's communication structure. So, if we shift our explainer here from an aviation failure to a timeless lesson in organizational theory, we see that Airbus's fragmented, siloed company inevitably produced a fragmented, disconnected airplane. Basically, the product always reflects the org chart, every single time.
All right, let's fast forward to today. We are seeing the exact same dynamic completely derailing modern technology deployments. Infotech Research Group predicts that by 2026, integration gaps will be the #1 bottleneck slowing AI and digital transformation. It turns out AI is acting like an incredible amplifier for these exact same invisible integration gaps, but now it's happening at software scale. Think about it. AI allows individual siloed teams to work way faster and generate far more volume than ever before. But when two of those teams have misaligned tools or differing definitions, their AI outputs simply reflect and amplify those misalignments with total automated confidence.
The modern fallout of ignoring Conway's Law is, honestly, pretty staggering. By 2026, McKinsey predicts that while 91% of companies will have deployed AI, a massive 94% of them will see absolutely no significant value from it. Only 6% are going to land in that tiny sliver of significant value. Why is that? Well, local AI acceleration combined with unchanged integration bottlenecks equals zero significant value for the vast majority of deployers. Every individual team's dashboard looks amazingly green because AI is speeding up their local node. But the project as a whole, it crashes the moment all those separate, misaligned pieces try to actually plug into each other.
Let's walk down the classic 5 Whys framework. This will help us strip away the symptoms and clearly expose the structural disease that's causing these modern AI delivery failures. Step 1. Why do these complex projects fail? Because integration risk simply isn't tracked. Step 2. Why isn't it tracked? Because there's no clear ownership over interface testing. Step 3. Why is there no ownership? Because accountability is strictly enforced only at the team level. Step 4. Well, why is that? Because our status architectures were built to track individual nodes, not the actual fit between those nodes. Which leads us to our ultimate root cause, Step 5. Because the fundamental governance structure remains totally unchanged for the AI era. We're looking at the exact same chain of root causes that destroyed the A380 schedule. It's just operating at a dramatically higher speed today.
So, how did Airbus actually get out of this massive mess? It's highly instructive. The ultimate fix wasn't a quick software patch or just installing a new version of CATIA. No, it was the brutal Power 8 restructuring program. It required a massive governance overhaul that finally addressed the root cause hidden in the org chart. They had to cut 10,000 positions. They had to physically relocate over 1,100 engineers just to hand-fit the harnesses. They forcibly harmonized the 3D toolchains and completely reorganized the company from national fiefdoms into truly transnational centers of excellence. The warning signal was in the airplane, but the actual fix had to happen in the boardroom. Now, the good news is you don't need to lose 4.8 billion euros or fire 10,000 people to learn this lesson. To prevent this kind of disaster in your own organization, you just need to execute a proportionally cheap but absolutely vital intervention right now. We call it the interface audit, and the rules are super simple. First, you need one named owner per interface. Second, one clearly agreed definition of what fit actually means across that boundary. And third, one hard confirmation date before integration ever occurs. Essentially, you are forcing accountability directly into that invisible space between your teams. Which brings us to the end. I want to leave you with a final provocative thought to take into your very next meeting. Who owns the interface in your program? And to be clear, I am not asking which team is responsible for their own delivery. I am asking which specific, named human being owns the space where Team A's work meets Team B's work. Because if that named person doesn't exist, your organization is carrying an Airbus gap. And in an era where AI is rapidly accelerating every individual team's output, it's really only a matter of time before the reality of that gap catches up to your beautifully green status reports.
So get out there and start auditing those interfaces today.